Okay, this is chapter 21, logarithm. We'll start right from question number 1. Okay, this is question number 1 of 1. So we are asked to evaluate and find the value of log 1 upon 64 to the base 4. So how do we solve this question is we simply write log 1 upon 64 to the base 4 equals to x. Let's suppose the value of this is x. Okay, say. Now this is a logarithm equation, so we will convert this logarithmic equation to exponential equation. Okay, how do we do this? This base 4 will remain as base and this x will come here as power. After that 1 upon 64 we write here. Now 4 to the power x we write as it is equal to 1 upon 64. Let's find the factors of 64 in terms of 4. Okay, we are trying to make base equal, so I'm finding the factors of 64 in terms of 4. Excuse me. 4 ones are 4, 2 in hand, 4 6 are 24, 4 4s are 16. 4 multiplied 3 times gives us 64, that is 4 cube, isn't it? So instead of 64 I write 4 and then I put a whole cube. Okay, or 1 cube means 1 and 4 cube means 64. 1 cube means 1 into 1 into 1, so that gives us 1, and 4 cube means 4 into 4 into 4 will give us 64. 4 to the power x equal to, this cube is for both the numbers 1 and 4, isn't it? So 1 cube is 1 and 4 cube means 4 to the power 3, or 4 to the power x, 4 to the power x equal to, now we have the power as positive 4 cube, isn't it, in the denominator. If we bring this number to the numerator, the sign of the power changes to negative, 4 to the power minus 3. Now let's continue this sum here. Since 4 and 4 bases are equal, that means their powers will also be equal. So we can write therefore x equal to minus 3. So this is the solution for question number 1 of 1. This is question number 2 of 1. We are asked to evaluate and find the value of log 0.000001 to the base 0.01. Okay, so how do we do this? We can write this as, let's suppose this as x. Okay, first log 0.12345 1 to the base 0.01 equal to x. We are supposing this is equal to x. Okay, say. Now let's convert this logarithmic equation to exponential form. Okay, so how do we do this? This base 0.01 will remain as base. To the power, this x comes here as power equal to this number 0.123450 and then 1. Now let's rewrite this number in another form after removing this decimal point. So we have 0.01, which means we have a decimal point before 2 digit, isn't it? So what do? We write 1 upon, we remove these decimal points and write 2 zeros in the denominator. Okay, 2 zeros means we are removing decimal point from 2 digit, before 2 digit. So this number can be written in the form 1 upon 100. Okay, whole to the power, this is x. Similarly, this number can be written as 0.123450 and then 1, isn't it? So we have 1 upon, decimal point is before 1 2 3 4 5 6 digits, so we forget the decimal point and write 6 zeros in the denominator. Okay, 1 2 3 4 5 and 6. So 1 upon 1 2 3 4 5 and 6. Okay, 1 upon 100 can be written as 1 upon 10 square. 1 square is 1. So 10 square means 100. 10 square means 100. So this 100 can be written as 10 square. So we already have x as power. So this is 2x equal to 1 upon 1, 2, 3, 4, 5, 6, isn't it? So this number can be written as 10 to the power 6. Okay. Now this 1 upon 1 to the power 2x is 1. 1 raised to any number as power. 1 raised to power x is 1. 1 raised to power 0 is 1. 1 raised to power 100 is also equal to 1. 1 raised to any number as power is always equal to 1. So 1 raised to power 2x is 1, isn't it? So this becomes 1. Now this 10 to the power 2x, isn't it? So 1 upon 10 to the power 2x equal to 1 upon 10 to the power 6. Okay. Now let me continue this sum here. So 1 upon 2x, we have the sign of power as positive in the denominator. Now if I take this number to the numerator, the sign of the power changes to negative, minus 2x. 10 to the power 2x becomes 10 to the power minus 2x. Because this was in the denominator, I took the number to the numerator. Okay. Similarly, in the right hand side also, the power of the sign of power is positive. If I take the number to the numerator, this becomes negative, 10 to the power minus 6. So this is 10 and 10. Bases are equal. That means powers will also be equal. Minus 2x equal to minus 6. If bases are equal, then powers will also be equal. This minus and this minus cancels out. X equal to 6 upon 2. This means 2 1s are 2, 2 3s are 6. Therefore, x equal to 3. So we got the value of x. X means this. This means the value of this number is 3. Okay. Therefore, log of 0.12345 is 1 to the base 0.01 is equal to 3. This is question number 3 of 1. So we are asked to evaluate log 216 to the base root 6. So let's suppose this is equal to x. Now this is a logarithmic equation. Let's convert this equation to exponential equation. Okay, exponential form. So root 6 is the base of the logarithm, isn't it? We write base as base itself. Now this x will come here as power. After that, on the other side we write this 216. Now this root 6 means 6 to the power half. Okay, if I have root 2, I can write as 2 to the power half. If I have root x, I can write this as x to the power half. So root 6 means 6 to the power half. So we already have x in the numerator, x as power, so this will remain as power. 216, I'm going to change this in 6 factors of 6. Okay, 216. This will give us 6 3s are 18, 19, 20, 21. We have 3 in hand, 6 6 are 36, again 6 6 are 36. 6 multiplying 3 times gives us 216. So this can be written as 6 to the power 3. 1, 2, 3. 6 cube. Or we have bases equal, isn't it? 6 and 6 are equal. This means power will also be equal. So 1 into x, x upon this 2 equal to this 3. Therefore, x equal to 2 will be multiplied to other side on the numerator, because this is in the denominator. Cross multiplication, 2 3s are 6. We got the value of x at 6. X means this, isn't it? Therefore, log of 216 to the base root 6 is 6. Okay. This is question number 4 of 1. We are asked to evaluate log 1728 to the base 2 root 3. Okay. So what we do is we suppose this as x. Log 1728 to the base 2 root 3 is equal to x. We are supposing. Okay. Now we convert this logarithmic equation to exponential form. Now the base of the logarithm 2 root 3 we write here. This x will come here as power, and then in the right hand side we have 1728. Okay, 1728. This is how we convert logarithmic equation to exponential form. Or this 2 root 3 to the power x we write as it is. After that, we find the factors of 1728. Okay, I'm trying to find the factors of 1728. Let me try with 12. So 12 ones are 12 plus 5 will give us 17. This becomes 52. 12 fours are 48. 4 in hand. This becomes 48. 12 fours are 48. 12 12s are 144. This means 1, 2 and 3. 12 cube 1, 2, 3 means 12 cube is equal to 1728. So instead of this number I can write 12 cube. Now what I'm trying to do is I'm trying to make the bases equal. Okay, so 2 root 3 we write here as it is, equal to, instead of 12 I can write 4 into 3. 4 3s are 12 to the power 3, or 2 root 3 to the power x, isn't it? So we have root 3 here, isn't it? We have root 3 here. So what we do is we write root under 4 into 3 square. Okay, and this 3 we should not forget, I write this 3 also. So 4 times 3, root under 4 times 3 square means root 2 square means 2, isn't it? Root 2 into root 2 equal to 2. Similarly, root x square means x. Similarly, 4 into 3 root square means 4 into 3. This number, isn't it? So when I square the root number, this square and the root will be cancelled and only the number will remain. So I am squaring this after putting the square root and this 3 here as it is. Now or 2 root 3 to the power x equal to square root of 4 is 2, isn't it? Square root of 4 is 2. Square root of 4 equals to root under 2 into 2. So we make the pair and bring out 2. So square root of 4 is 2. I write 2 here. So this 3 will remain within the bracket 2 root 3. After that, the power of this number is 2 3s are 6. Let me continue on the other side. So we have the bases equal 2 root 3 and 2 root 3. This means the power will also be equal. Therefore, x equal to 6. So x is this number, isn't it? Therefore, I can write log of 1728 to the base 2 root 3 equal to 6. So this is the solution. Question number 2a. Find the base if logarithm of 625 is 4. Okay, so we are asked to find the base if log of 625 is equal to 4. This is given to us. So let's suppose let the base of logarithm be x. Okay, I am supposing the base of logarithm as x. Now given to us log of 625 is equal to 4. Logarithm of 625 is equal to 4. So we have assumed the base to be x, isn't it? So I am writing x as base. Now what we do, we convert this to exponential equation. So this base x I write here, this 4 will come here as power equal to this 625. Okay, now this x, this is power 4, isn't it? So if I take this power 4 to the right hand side, this becomes 625 to the power 1 by 4. Okay, if I have x square equal to m, if I have x square equal to m, then if I take this square to the right hand side, this will become root m, isn't it? So root m means actually m to the power half, isn't it? So x to the power a, if I have x to the power a, I can write m 1 to the power a. This a will go to the denominator as power. Okay, so this 4 was in the numerator in the left hand side. If I take to the power in the right hand side, this will 4 will go to the denominator of power. Or x equal to 6 to 5 means, let's find the factors of 6 to 5 in terms of 5. Okay, 6 to 5, 5 12 is 60, 2 in hand, this becomes 25, 5 5 is 25, 5 2 is 10, 11 12, 5 5 is 25, 5 5 is 25, 1 2 3 4, 5 to the power 4, isn't it? 6 to 5 means 5 to the power 4 into this 1 upon 4. So this 4 in the denominator and this 4 in the numerator will be cancelled. Therefore, x equal to, we have 5. 5 to the power 1 means 5, isn't it? So we got x equal to 5, and x was the base of the logarithm we had supposed earlier, isn't it? Therefore, the base of the logarithm, base of the logarithm is 5. Question number 2b. Find base if logarithm of 5832 is 6. So let the base be x. Let the base of the logarithm be x. Okay. Now we have log 5832 to the base x equal to 6. We are asked to find the base, the value of x. Okay. Now we convert this to exponential form. This base x we write here, this power will come here as 6 equal to 5832. 5832. Now let's find the factors of 5832. 5832. 2 2s are 4, 5, 1 hand, 2 9s are 18, 2 1s are 2, 3, 2 6 are 12, 2 1s are 2, 2 4s are 8, 1 9, 2 5s are 10, 11, 2 8s are 16, 2 7s are 14, 2 2s are 4, 2 9s are 18, 9 8s are 72, 9 1s are 9, 9 9s are 81. So 2 2 2 and 9 9 9. That means 2 cube into 9 cube. 1 2 3, 2 cube, 1 2 3, 9 cube. Or x to the power 6 equal to 2 into 9 whole cube, isn't it? 2 cube into 9 cube means 2 into 9 whole cube. Okay. So x to the power 6 equal to this, let me take this 6 to the right hand side. Okay, the power 6 to the right hand side, 2 into 9 whole to the power 3 into this 6 will go as 1 upon 6 to the other side. Now 3 1s are 3, 3 2s are 6. Or x equal to 2 into 9 to the power 1 in the numerator and 2 in the denominator, 1 upon 2. Or x equal to 1 upon 2 means root, isn't it? So x equal to, this 1 upon 2 power is for both the numbers 2 and 9, both are within the bracket. So this becomes root 2 into root 9. Okay. Let me continue here. Or x equal to root 2 is root 2 and root 9 is 3. Root 9 means 3. Okay. 3 3s are 9. So we make pair and free from the root. So this will give us x equal to 3 into root 2. So 3 root 2. Therefore, x means the base of the logarithm, isn't it? We had supposed the base of the logarithm. So base is 3 root 2. This is the solution for question number 2b. Question number 3a. If 1 plus log a to the base 10 equal to 2 log b to the base 10, express a by b. So we are asked to express a in terms of b. This is the given equation. Before doing this question, let's see the rule which will be needed to solve this question. Okay. Suppose if we have log of a to the base a, if log of number to the same number as base, then the value will be equal to 1. Okay. Log of 10 to the base 10 is equal to 1. Log of 2 to the base 2 will be equal to 1. Log of a number to the same number as base will give us 1. This is the first rule which we should know. And another rule is, if we have log m plus log n. Okay, and if the bases are same, suppose 10 and 10, log m to the base 10 plus log n to the base 10. This can be written as log m into n to the base 10. Okay, this is another rule. If we have plus between two logarithms of same base, then we can multiply like this and the base will remain as it is. Okay, but if we have log m to the base 10 minus log n to the base 10, bases must be equal and there is a minus sign opposite to plus. Okay, then we write this as log m upon n to the base 10. If we have plus sign, we write multiplication sign here. If we have minus sign, we write division sign here, m upon n. Okay, these are the rules that will be needed to solve this question. So first, this is the equation given to us, 1 plus log a to the base 10. So what we do is we write log 10 to the base 10 instead of this 1. Okay, log 10 to the base 10 is 1, isn't it? So plus log a to the base 10 equal to, okay, another rule. If we have a log m, okay, if we have a log m, suppose the base is 10, now this can be written as log m to the power a. This a will go here as power to the base 10. This a is this a, okay, the coefficient a will go here as power. I hope you got this. If we have log x square, then we write this 2 here as 2 log x. Okay, now we have 2 log b, isn't it? 2 log b. So this can be written as log b square to the base 10. Now log 10 to the base 10 plus log 8 to the base 10. Both of these logarithms have same base 10 and 10, and there is a plus sign in between these two logarithms. So what do is we write log 10 into a, 10 into a to the base 10. Bases must be equal to apply this. Okay, log 10 to the base 10 plus log a to the base 10. Bases are equal, there is a plus sign, so we write log 10 into a to the base 10 equal to log b square to the base 10. Now we have log to the base 10 and log to the base 10 in both the sides, isn't it? So in this case, we can leave log from both the sides. We should not cancel log, okay? We can leave log from both the sides. So this log to the base 10, log to the base 10 is left. 10 into a equal to b square is in the right hand side. 10 into a equal to b square, or a equal to b square upon 10, isn't it? So this is the solution. This 10 will go to the denominator, so a equal to b square upon 10. We were asked to express a in terms of b, isn't it? So a in terms of b is a equal to b square upon 10. Question number 3b from chapter 21, logarithm. Okay, so we have 3 plus log x to the base 10 equal to 2 log y to the base 10, and we are asked to express x in terms of y. So what we do is, this 3 we write here as it is, and we can consider as 3 into 1, isn't it? 3 into 1 is 3 itself, so we can write 3 into 1. So instead of 1, I can write 3 into log 10 to the base 10, isn't it? 3 into log 10 to the base 10. So log 10 to the base 10 is 1. So 3 into 1 is 3, isn't it? So 3 into log 10 to the base 10 is basically 3 log 10 to the base 10. 10 to the base 10 is 1. So 3 into 1 is 3, plus log x to the base 10 equal to, let's take this 2, log y to the power 2 to the base 10, log y square to the base 10, or here we have 3, so we take this 3 as power of 10. Okay, log 10 to the power 3 to the base 10, log 10 cube to the base 10, this 3 goes to the power of 10, plus log x to the base 10 equal to log y square to the base 10. Now we have log base 10, log base 10, and there is a plus sign in between these two logarithms. So what do? Log 10 cube into x to the base 10. Okay. To apply this formula, bases must be equal to log y square to the base 10. Now we have log base 10, log base 10. So we can leave log base 10 from both the sides. We should not cancel log, okay. We can leave log from both the sides. So we have 10 to the power 3 into x equal to y square is in the right hand side. Or this x we write in the left hand side equal to y square upon this 10 cube means 1000, isn't it? 10 cube means 10 into 10 into 10. This is 1000. So this 10 cube we take to the denominator on the other side. Okay. So x equal to y square upon 1000. This is the solution.